All right, this is the intro video for Algebra 1 Enhanced, section 5.1, and we're going to be looking at rules for exponents. So, to get us started here, we're going to review the parts of an exponential expression. In this particular expression right here, we would call the 5 a base, and we would call the 4 the exponent. Notice that the exponent is a superscript. It's up high, it's smaller, whereas the base is a regular sized number and a little bit lower. Okay, so the meaning, 5 to the 4th power, or 5 to the exponent of 4, means this: 5 times 5 times 5 times 5. And essentially 5 times itself 4 times. So what I want you to do here is take a minute and look at 1a and 1b. I want you to decide what the base is and what the exponent is for both of these expressions. So in letter A, the base is 3x, and the exponent is 5. So you have a base of 3x and an exponent of 5. So that essentially means that 3x in parentheses to the 5th means 3x times 3x, so on and so forth, 3x times itself 5 times. Okay, and then in B, because the parentheses aren't there, this means something a little bit different. In this case, the base is x, and the exponent is 5. So this basically means 3 times x times itself 5 times. It's a little bit different. You can see up here in A that this will end up being quite a bit of a different expression. In fact, 3 times itself 5 times is 243. Of course, x times itself 5 times is x to the 5th. And down here, this would just be 3x to the 5th. So in this, I want you to try to go the other way. I want you to take A and B, and I want you to try to write these as an exponential expression given the set of factors that we have on these. So take a minute and try those. All right, so for 2a, we would write this first product like this: parentheses 3x, close parentheses, to the 4th, right? Because there are 1, 2, 3, 4 of those factors. And in B, we can see that there are 1, 2, 3, 4 x's multiplied together. So this would just be 3. You could write it like this if you wanted to, or the more customary way would probably be to write it like this. This means that the 4 exponent applies to the x, which is the base. The exponent of 4 right here does not apply to the 3. Up here, the exponent of 4 does apply to both the 3 and the x. Okay, now we're going to take a look at a couple of rules for dealing with exponential expressions. So the first one is called the product rule. And the product rule says this: if we are multiplying exponential expressions with the same base, we are going to keep the base the same, and we will add the exponents. So an example of this would be right here: x to the m times x to the n. Notice that the bases are the same, and we are multiplying those bases together. So this would result in x to the m plus n. When you get to class, we'll look at maybe some reasons why this rule is, but for now I want you to kind of get used to the name, the product rule, and what it means. The next one is the quotient rule. So in this one, we are going to be dividing exponential expressions with the same base. In this case, once again, we are going to keep the base the same, and instead of adding the exponents, we are going to subtract the exponents. Okay, so you can see down here we have a quotient. We're dividing two bases, the same base, both x's. So in this case, we're going to subtract the exponents. We always subtract top minus bottom, so it'd be x to the m minus n. Okay, now we're going to look at one final rule and kind of an extension to this final rule. This final rule is called the power rule. In this, we're going to be raising an exponential expression to a power. So if we're doing that, we are going to keep the base the same. I hope you've noticed that common theme here. We're going to keep the base the same, and we will multiply the exponents. We're only really working with the exponents here. So what I have here is I've got an exponential expression raised to a new exponent. And so what I will do is I will keep the base the same, and I will multiply the exponent. So it'd be x to the m times n. It's really important that we keep track of what is a base, what is an exponent, and deal with them appropriately. And then finally, this extension here, the power of a product or the power of a quotient. To raise a product to a power, we're going to raise each factor to that power. To raise a quotient to a power, same thing. We're going to raise the numerator and denominator to that power. So this would be, on the left down here, this would be x to the m times y to the n to the p. So what I'm going to do is I'm going to multiply my exponents. It's going to be x to the m times p, y to the n times p. So that p applies to both. It gets multiplied into both the m and the n. And then same idea over here. This would be a quotient raised to a power. And so we are going to multiply the exponents again. It's going to be x to the m times p over y to the n times p. Okay, so I've got a couple of examples I want you guys to work on here to make sure you have a decent handle on this. We'll practice more when we get to class. So take a look at the next page. So here you can see 3 questions to help us get a check for understanding. And so I want you guys to pause the video, try these, see what you can do. I hope you do well, but if you don't worry about it. We'll keep practicing in class. But do give these a try. Pause the video and you can check the answers in a second. Okay, number 1, we have x to the 3rd times y to the 4th to the 5th. So this is really similar to one we just did. This is the power of a product. And so what I'm going to do is I'm going to take both of the factors inside. I'm going to raise them to that 5th power. And in order to do that, I need to multiply my exponents. And so this would end up being x to the 3 times 5, which is, of course, is 15. Y to the 4 times 5, which is 20. And that would be our final answer there, x to the 15 times y to the 20. Please note, really important, that we cannot combine these two bases because they're different bases. One is x, the other one is y. And so we have to leave those separate. If they were both x's or both y's, we, of course, could combine them. Okay, number 2. Number 2, this one I would say is probably the trickiest of this group. We've got a quotient raised to a power. It's really important that we realize that this exponent, this 3 out here, is going to apply to all of the factors inside the quotient. So this exponent of 3 applies to the base of 2, the base of x cubed, and the base of y to the 5th. And in each case, we're going to multiply the exponents. I am going to save the 2 for the end because that is probably the most commonly mistaken part of this. So I'm going to focus first on this x to the 3rd. And so x to the 3rd to the 3rd, I'm going to multiply my exponents, and I'm going to get x to the 9th. And then y to the 5th, once again, I'm going to multiply my exponents. Y to the 5th to the 3rd is really y to the 5 times 3. So that's y to the 15. And then lastly, the 2. I want you to think about this for a second. I want to give myself a little more room here. The 2, I want you to think about this. Is the 2 an exponent or is the 2 a base? The 2 is really a base. And we want to think about the exponent on the 2. The exponent on the 2 is really a 1. Right? It's not written, and we understand it to be a 1. So this is 2 to the 1st to the 3. So we would write this as 2 to the 1 times 3. Or of course, just 2 to the 3rd. And then we could simplify this one step further. Of course, we know that 2 to the 3rd is 8. So this would be 8x to the 9th over y to the 15th. The most common mistake here is to write a 6 instead of an 8. But in that case, you're multiplying a base times an exponent, and we will never do that. We'll always multiply exponents or add exponents or whatever, but we will never multiply a base times an exponent. So this would be our correct answer here. Okay, and then finally we have number 3 down here. A couple of steps to this one. Let's do this step first. I've got x to the 9th over x to the 4th. Notice they're all x's. This is our quotient rule from before. If I am dividing like bases, then I subtract my exponents. 9 minus 4, of course, is 5. Oops. 9 minus 4, there we go. We still have that times x to the 8th. So this gives us x to the 5 times x to the 8. And now let's remember the very first rule we looked at, that is called the product rule. And the product rule applies when you are multiplying bases together. You add your exponents. So this would give us x to the 5 plus 8, and of course 5 plus 8 is 13. So this would give us x to the 13th right there. Okay, I hope that worked for you. We'll practice these a lot when you get to class. See you then.